Hi, this is Pratik and welcome to Code by Pi. In this video lesson, we'll learn about how to detect cycles in a directed graph by using the stack of iterators method. So this is the code from my previous tutorial where I showed you how to do depth first traversal by using stack of iterators method. So I'm going to use this code and I'm going to add a few more lines of code into it. So basically, cycles can be detected by using depth first traversal only. So I'm going to again follow the same stack of iterators approach because it avoids recursion and it's a bit fast. So I have talked a lot about stack of iterators in my previous tutorial. So if you have not watched that, please go and see that. So this is the graph that we'll be continuing. So in this graph, as you can see, there is a cycle from 1 to 0, and that has been marked with orange. And there's a cycle from 3 to 0, and that has been marked with orange. The cycle basically means you could go from 0 to 1, and from 1 you could go to back to 0. So this is like a continuous. Again, you could go from 0 to 1, then 1 to 3, then from 3 you could go back to 0. So this is again a continuous movement. So if I ask you whether this is a cycle or not, so what would be your answer? So actually this is not a cycle, because if we start from 0, then we go to 1, and from 1 we go to 2, but from 2 we cannot go back to 0. So there is not a continuous movement. If things would have been a bit different here, like if the arrow was pointing like this, then yes, it would have been a cycle, because it then would have become a continuous movement. Like from 0 to 1 we could have gone, and then from 1 to 2 we could have gone, and then we would have gone to 0. So this is like continuous movement, and it would have become a cycle. So now, since your concept of cycle is clear, now let's move ahead. This result out here is actually the depth first traversal order. Like if we detect its traversal, then the order printed out is this. For finding cycle in this graph, I would make use of a stack, and I will call it as recursion stack. And this stack would contain those vertices which are present in the recursion. By this I mean that if we start from 0 and try to do depth first traversal, then 0 will be appended into this stack, and then we move to 1, so 1 will be appended into the stack, and now we move to 3, so 3 will be appended into the stack. From 3 we go to 0, but we cannot go to 0 because 0 has already been traversed, so we won't be going from 3 to 0. So from 3 basically you cannot go anywhere. All right, so when this happens, then you're gonna pop out from the end of the stack. So the stack will contain those vertices which have been traversed, but the edges from those vertices have not been completely explored. Like here 0 is present in the stack because 0 has been traversed, but all the edges originating from 0 have not been traversed. Okay, so we have already explored this path, but we are yet to explore this path. So since all the paths from 0 has not been explored yet, therefore 0 will remain in recursion stack. We popped out 3 because when we traverse 3 and then we saw all the paths originating from 3, there was only one path originating from 3, and that led us to 0, but we did not go to 0 because 0 was already traversed. So except this path, this orange path, rest there were no other paths. So basically I should say that we had already explored all the paths originating from 3. So there is no use of 3 remaining in the recursion stack anymore. Therefore we popped it out, because there would have been no other nodes that would have led us back to 3. Okay, so this is not the case. So there is no other node that could have led us back to 3, so there is no use of 3 remaining in the stack anymore. But there can be edges that would lead us back to 0. So 0 remains in the stack, and there can be edges that can lead us back to 1, because we have only explored this path, and this path from 1 is yet to be explored. So it might have been possible that there was a case in which 4 led us back to 1. So in that case, we would have looked into the recursion stack. We would have seen that yes, 1 is present in the recursion stack, which means if 4 led us back to 1, then we would have matched this entry, and we would have seen that whether that entry is present in the recursion stack or not. So 1 is present in the recursion stack, and 4 led us back to 1, which means the cycle was present. So I hope that the idea of using a recursion stack is clear to you. For now, just move ahead. So in this code, first we're going to create a recursion stack, and I am going to put it here. So recursion stack is r_s, and that will be initially empty because we have not yet started traversing the graph. And just remember that in this recursion stack, we will be appending those vertices which are in recursion. And then whenever we visit a node or a vertex, we gonna append that vertex inside this recursion stack, and after that we make an iterable object of the list associated with whatever we traversed here. So it contained a list associated with it, so the key had a list associated with it. So we got that list and made an iterable object out of it, and then appended it with a stack. So this stack is different from rs. This is some other stack which is the stack of iterators. So this stack is the stack of iterators, and this is the recursion stack. Do not get confused. All right, so we had this recursion stack which was initially declared as empty. Now 0 was traversed, so 0 got appended into this recursion stack. And also we had a big stack of iterators in which a list was present containing elements 0, 1, 2, 3, 4, and 5, because that's what we initialized stack with. We initialized the stack of iterators with an iterable object which contained elements ranging from 0 up till the num vertex. So if the number of vertex is 6, then list range certain number of the vertex gonna generate a list containing elements from 0, 1, 2, 3, 4, and 5, and then we're gonna convert that list into an iterable object. So since 0 has been traversed, so in this stack of iterators, the list corresponding to 0 will get appended. So now after this step takes place, the for loop will exit by a break statement, and the while loop again continues, and this time it picks up the last iterable object from the end of the stack and then iterates over it. So this time I becomes 1, because now our code iterates over this list. So it takes I as 1. So 1 is not yet visited, so it prints 1 and then visits 1, and then it appends 1 into this recursion stack. So in this recursion stack, 1 gets appended, and the list corresponding to 1 gets pushed inside this stack of iterators. So again, the for loop exits by using the break statement, and the while loop reruns, and when the for statement in the while loop runs, it makes I as 3, because stack minus 1 is the iterable object list containing elements 3, 4, and 0. So first it's gonna take 3, so I becomes 3. It visits 3, prints 3, and it visits 3, and then it appends 3 inside this recursion stack. So this was the recursion stack, and now 3 will be getting appended. So after 3 gets traversed and appended, the list corresponding to 3 gets appended into this stack of iterators. So this list gets appended having element 0. Again, the while loop breaks, the for loop breaks, and again the while loop reruns. So when the while loop reruns, it picks up stack -1, and when it tries to iterate over it, I becomes 0, and it sees that if visited I equals false. So 0 has already been visited, so it will not visit it again, which means that these all statements will not execute. So since 0 has already been visited, therefore there stands a possibility that there is a cycle is present in this graph. So we're gonna make some changes. First, I am gonna remove this break from here, and then I am gonna add this elif statement saying that if in case visited I becomes true, then it will come to this else if statement, in which it will check if that I is already present in the recursion stack. So if that I is already present in recursion stack, which means that yes, cycle is present, and I am going to print that cycle, and I am going to say that cycle is present from rs -1 to I. This rs -1 basically denotes the end element present in the recursion stack. The end element present in the recursion stack is 3, and it would signify that there is a cycle from 3 to 0, because I is 0 here, and that stands perfect. And after that, we're gonna break. This break has to be present outside elif, because it has to break even if this elif statement doesn't get executed. So either if statement get executed or elif get executed, the for is gonna break. So after the for gets broken, the while loop reruns, and this time it executes the for statement, and it picks from the end of the stack. So it picks the iterable list object having element 0. So but then it would remember that it had already worked with 0. Therefore these statements do not get executed. Therefore we directly come to the else class, in which it's gonna pop from the end of the stack of iterators. And also notice that we have done with 3 because we have observed every possible connections originating from 3, and we cannot go anywhere else from 3, which means that there won't be any connections coming back to 3. So which means the presence of 3 inside this recursion stack is meaningless. Therefore we're gonna pop this 3 from this recursion stack. Therefore in our code I'm gonna mention that we are also gonna pop from the recursion stack, and we're gonna print it. If you are interested, you can print it. So pop from the stack of iterators, and also pop from the recursion stack. So 3 gets popped from the recursion stack, and the while loop again continues. So since the while loop continues, checks while stack, yes, stack has some objects. So this for loop again runs, and it picks up from the end of the stack. So it picks up the iterable list object having elements 3, 4, 0. It sees that it has already worked with 3, so now chance comes for 4. So our I becomes 4. It sees that if visited I equals false, yes, 4 has not been traversed, so it prints 4 and changes the value of 4th index of visited list to true, and appends 4 inside this recursion stack. After 4 gets appended, it takes the list corresponding to key 4 and appends that inside this stack of iterators. So it appends the empty list. And this is actually an object, because before appending it into this stack of iterators, it converts this list into an iterable object. After this, the break statement takes place, which means it breaks the for loop. Now again the while loop continues. It sees that while stack, yes, then it's gonna pick up from the end of the stack of iterators, and this time it picks up the empty list object. So since the empty list object is empty, therefore you cannot iterate over that object, which means I cannot hold any value, which means this for loop terminates normally without using the break statement, which means it comes to this else class in which it pops from the stack of iterators and pops from the recursion stack, and then it's going to remember that it has already worked with 4. Again the while loop continues, and it's going to check while stack, yes. Again the for loop gonna start, and this time it's gonna pick from the end of the stack, and that iterable list object has elements 3, 4 and 0. It remembers that it has already worked with 3 and 4, which means now I directly becomes 0. It sees that if visited 0 is equal to false. No, visited 0 is true because we have already visited 0. Therefore, these statements do not execute, and we directly comes to this elif statement in which it checks that if I is present in recursion stack. So yes, 0 is actually present in the recursion stack, which means it will print that there is a cycle from 1, rs minus 1 is 1, and say that there is a cycle from 1 to 0 because I is 0. And there is indeed a cycle from 1 to 0, you can see here. And also to remember that it has finished working with 0. So now it will execute the break statement, the for loop will break, and the while loop will restart. So when the while loop restarts, it again executes this for statement in which it picks from the end of the stack, and that stack iterable list object has elements 3, 4 and 0, in which it has worked with 3, 4 and 0. So there is no leftover elements to work with. Therefore this for loop terminates normally without using the break statement. And since this for loop terminates normally without using the break statement, therefore our execution of the code comes to this else class in which it pops from the stack of iterators from the end, and also pops from the recursion stack from the end. After this, the while loop continues, and when the while loop continues, it again runs the for statement in which it picks from the end of the stack. So the picked list object is the list having elements 1 and 2, in which it sees that it has already worked with 1, which means the only element left to be worked with is the element 2. So I directly becomes 2. And then it checks if it has visited 2. So 2 has not visited, therefore it's gonna print 2, change its corresponding index in visited list to true, and then append 2 inside the recursion stack. And after this, it's gonna take the list corresponding to key 2, and it's gonna append that list inside this stack of iterators. Now again the while loop reruns, and this time when it reruns, it again executes this for statement in which it picks from the end of the stack, that is the list object having no element in it, which means the list is empty, which means I cannot take any value, which means the for loop terminates without doing anything. And since the for loop terminates without using the break statement, so it's going to come to this else class in which it's again going to pop from the stack of iterators, and it's going to pop from the recursion stack. After this, the while loop continues its execution, and again the for loop reruns in which it picks from the end of the stack, that is the stack having elements 1 and 2, but it remembers that it has already worked with 1 and 2, and there is no more elements left to be worked with. So this for loop terminates without using the break statement. Therefore it comes to the else clause in which it pops from the end of the stack of iterators and also pops from the recursion stack. After this, the while loop continues. It executes the for statement, picks up from the end of the stack, that is the list object having elements 0, 1, 2, 3, 4, and 5. It sees, and so now I becomes 1 because it has already done working with 0, so I directly becomes 1. It sees that 1 has already been visited, which means these statements do not run, and it directly comes to this elif path in which it checks if 1 is in the recursion stack or not. So you can see that the recursion stack is empty, 1 is not present in this recursion stack, so there is no possibility of cycle. So since 1 is not present in the recursion stack, it's gonna break, and after the break is performed, the while loop again reruns, and again the for loop runs, and this time again picks from the end of the stack, and after that it picks up again the same list object. Now I becomes 2 and sees that 2 has already been visited, therefore it comes to this elif part in which we check if 2 is present in the recursion stack. So 2 is also not present in the recursion stack, so again it breaks. Again same things happen for 3, 4, and when I becomes 5, then it checks if 5 has been visited. So 5 has not been visited, which means it's going to print 5, and it's going to visit 5, and it's going to append 5 inside the recursion stack at the end of the recursion stack. So after 5 gets appended inside this recursion stack, our code is going to get the list associated with key 5 and then append it inside this stack of iterators. Now since this if statement has taken place, so this elif statement will not take place, and our code is gonna come to this break statement in which it's gonna break the for loop. Again the for loop reruns, and it's gonna start this for loop. Again the while loop reruns actually, and it's gonna again start this for loop in which it again picks from the end of the stack, and that's an iterable list having element 4. So I becomes 4 and sees that if 4 has been visited or not. So since 4 has been visited, therefore these statements do not take place, and our code comes to this if statement, and it checks if 4 is present in the recursion stack or not. So since 4 is not present in the recursion stack, therefore this print statement will not get executed, and now our code will break the for loop again. And now it's gonna remember that it has already done working with 4. So when the while loop again reruns and this for statement again runs, it's gonna pick from the end of the stack, that is the list having element 0, but it remembers that it has already worked with 0, so there is no more elements left to be worked with. Therefore this for loop terminates normally without using the break statement, and it comes to the else block in which it pops from the end of the stack and pops from the end of the recursion stack. After this, the while loop reruns and again runs the for statement, and inside this for loop it picks from the end of the stack. Now it remembers that it has already done working with 0, 1, 2, 3, 4, and 5, and there's no more elements left to be worked with, so therefore the for loop will terminate normally without using the break statement. So it comes to the else class and pops from the end of the stack, and it checks if the length of the recursion stack is greater than 0, then pop from the recursion stack. But in this case the recursion stack is empty, therefore its length is not greater than 0, therefore these statements will not get executed. So that's the reason I used this condition before popping from the recursion stack. If I had not used this condition, then this would have returned an error signifying that you cannot pop from the recursion stack when it is already empty. So this if statement takes care of it. So finally we're going to pop from the stack of iterators, and it will also become empty. And now again the while loop tries to rerun, but this time the stack is empty, therefore the while loop does not run again. So the overall execution of the code comes to an end, and if we call the stack of iterators in the main function, And if we run this code, then we're gonna see this output, that it finds that there's a cycle from 0 to 0 and there's a cycle from 1 to 0, which is as according to the example. And we can also see the popped out items while the code runs. So now I'm going to comment this print statement out. So I'm going to comment it out so that output looks a bit decent. And then if I again rerun it, you can see that when our code reaches 3 and tries to go to 0, it finds that there's a cycle from 3 to 0, and then it prints 4, and then it cannot go any further from 4, so it comes back to 1. So when it comes back to 1, it tries to go this way, and when it tries to go this way, it finds that there is a cycle from 1 to 0. Therefore, it prints that out. There's a cycle from 1 to 0, and then it goes to 2, prints it, and then it goes to 5 and print it. So this is the overall execution of the code to detect cycle in a directed graph using stack of iterators. So I hope that you understood this tutorial. Like and share this video and subscribe to the channel, and thanks for watching.